do this test at various speeds. The magnet's been cleaned, no material on the magnet. And we'll peer inside the chute in low level light. We're going to get some assistance with some light here. We're running off what was left on 40 belt, the powdery coal. You can see that now. The belt's going to come clean here shortly. The belt is moving at half a mile an hour here. Fine silt-like powder. So this shot is simply to go back here and pick up the tail pulley, or the head pulley. There's a head pulley. The coal will launch into this chute. You creep down here, you see the hard hat. That is the gap between the bottom of the magnet and the spill out onto the walkway. We'll be watching very carefully to see whether coal does or does not flow out through that gap where you see the hard hat. We're going to swing around this other side and pick this up.
Just give me shine the lights up through here.
So there's the magnet. There's our gap. We're standing on the walkway to take this picture. There's the...
Just shine and lighten up the arrangement in there. Cole, can you zoom in on that?
Well, I'll try zooming, but zooming in these darkened conditions, this camera seems to struggle with zoom.
Are you picking any of that up?
Oh, we're picking that up, yeah. It's a little bit blurry, but we're getting a shot.
So I want to see the voids. That's the area that measures 19 inches. That deflector plate.
Oh, you want, okay, hang on, Kenny. I see where you want to go.
Yeah.
Just a sec. We can get that.
Watch the magnets on so you might kill your camera, right?
This is the spill detector plate here. If the coal projects itself out or plugs in the chute, sufficient to push that orange plate out, then the belt will stop detecting the plug up. We'll pick up this here. Okay, Kenny, if you shine your lamp in there a little bit on there, we'll try and get the difference where the coal, okay, there's the coal flow. If it hits this front plate, you can see the walkway behind the front plate. 40 belt is running at 256 feet per minute. The next car that dumps here is going to be 350. So here's your flow skipping underneath the 40 magnet at 256. This is just a picture of the backside of the flow leaving 40 belt, picking up the 40 magnet. There's our clearance, and this is at 256 feet per minute. The flow is now dropping off. The next car will dump, and we'll be increasing the speed to 350. Okay, I'll try and go from here. I'm looking down into the 40 head box. Ken's got the light. We're going to try and zoom in here. You want that plate identified? Here's at 350, the launch of the coal. If there was any material on the magnet, it would be plowing the coal left and right, and the coal would be scouring any material caught on the magnet. Kenny's going to illuminate the open area underneath this front plate. This front plate drops down about 20-something inches, and then there's a cavity. Here's the cavity that we're trying to get. We'll zoom back out. There's the open cavity.
Here on the chute.
See the wear pattern on the chute that Ken's illuminating with the light? It's an open cavity underneath. I can't get closer, and if we zoom, we seem to go and lose any clear image.
Okay. So when you show it the next time, show it that's the profile. It'll never get any brighter than that.
I did do that, okay. We're now 400 feet per minute. As Ken says, that regulator plate on the number 1 feeder or number 1 hopper sets the tone as to how high the coal can be. You go down into here at 400 feet per minute and look at the turbulence and starting to get close to spillage. The next car we're going to go up to 450.
Okay. 450's coming at us. It's underneath the magnet, Cole.
It's actually hitting the magnet at 450. It's right on the lip, the cusp from spilling. It takes very, very little and we would be spilling at this rate.
But if you had that modification, you'll go right by it.
Yes, with the modification it would be, except for, I don't know how metal or material stuck on the magnet would survive that type of scouring. I think it would tear the metal off. We're getting some spillage here now. You can see the coal spitting out of the chute.
Minor.
Flow is dropping off. Okay, we're stopwatching this. This is a 468-foot flow, which is our current wide open speed. At this moment, we can't dump faster.
Just barely touching the magnet, just skimming it very lightly.
Blowing through the holes in the front plate here.
Yeah. Empty.
72 seconds stopwatch from the time the car started turning to the emptying of the pit. This next time we're going to watch coal hit the belt and start the stopwatch at that point. We'll do one more car
Okay.
for our test.
No, absolute no slowing up the hopper.
No spilling at the hopper,
No plugging.
no plugging down below, and this modified spill plate wing.
No, that's not bad. I done that.
I know, but that helped.
Oh, yeah.
I think that helped from watching.
Oh yeah, oh totally.
From past
See,
practice.
and I can get room on this side as well by doing the
Because
same thing.
if that wing had not been turned out
Yeah.
and all that force was flowed over to this side, I think we'd have a problem.
Yeah.
We
Yeah.
should go and have a look at 107 loading and see what it looks like. Get a video cam of it coming out of the dumper. So we'll do this car and then I'll pop out to 107.
Okay. You probably won't
get
see much
video.
difference down there.
No, probably not.
30.
Okay, coal has just landed on the belt. So we're going to have a stopwatch of coal on belt to no coal on belt. Underneath there and see the flow to the magnet. Coal spitting out of the various holes. Tremendous force against this plate. Probably see from the vibration. 468 feet per minute. Just looking at the spill plate, the next car is going to dump. It's still at 468 feet. And we'll see, we'll just keep a good eye on this spill plate at that flow rate. Car is dumped. Beside me. This flow is right over to the wall here on the side. See if we can pick this up. It's a full flow right to the edge. Get my finger here. Right to the edge of the metal side skirts. Full flow, turbulent flow. If there was anything on the magnet that plowed coal, I think coal would be skipping over this edge and spilling. Now this may be a pleasant surprise that 468 107, we're going to get some photos of 107, but this belt is quite centered on the pulley, favoring the right side slightly.
Sounds okay out there, boy?
I think it's improved it.
That's what I'm thinking.
We're going to walk up the side here and get the photos we're looking for. We see no new spillage coming out the side at 107. Around the tail pulley. They're not dumping right now though, are they?
Let's go up and see. I want to see the speed on the belt.
But we're not dumping. I don't hear any turbulence right at the moment. We're at the top of 107. We're looking at the coal flow. And Kenny and I are both of the opinion the extra flow has actually balanced the belt out. It looks very centered. Pretty happy about this result.
That's perfect.
It is perfect. Here's the delivery down 109 Tower on the 151 at the north end. A very even flow, and this is still at 468. Maybe slightly driving and favoring the right side. You see, Ken, slightly favoring the right. Dramatically so? No. A certain amount of belt wander is inevitable anyhow. Just gonna watch this for a few more seconds, make sure there's nothing unusual happening. Everything looks good. We're going to go and time the pit emptying from up top, and then we'll call the test complete. Car is just dumping. We have not started the stopwatch. We're going to wait. There, car go on. Go ahead.
I haven't made any changes in the programming to get us to go that speed. Everything that got the more speed was from Brian at NorCap. Did you want me to make a programming change to restrict it back to 350 a minute, or what would you like?
We're still running this one out at 468. We'll carry on with that, Jim. We're going to do one more car. One more car at 468, and then we can go back to the normal cap, which I believe was 380 or thereabouts.
I understand that, Cole. It's just that the speed increase came from pumping Brian with the hydraulics. He either has to set the hydraulics back to what they were, or I can make a programming change to restrict it.
We'll be getting Ryan to set the hydraulics back. Kenny, I didn't get it on. Car's just dumping. Okay, this time we're going to try and pick up which pits are emptying first, second, third, fourth. And from up top, do a stopwatch as to how long it takes for the pit to empty.
Well, I'm just going to say the number, okay?
Yeah, okay. We're looking at pit number 3. Traditionally always our problem pit until a year or so ago. Not really any particular problem child in the pits. 4, if anything, with really difficult coal. 4, if we don't run wide open, may have a bit of a problem with rat holing in number 4, but it's not frequent. Overall, pretty happy. 4 is cleared. 3 pits cleared. We're in 1 minute. 1 is cleared. 1 minute and 4 seconds.
3.
3 is fully empty,
2.
and that's 68 seconds to clear. All pits. Number 2, sorry. 68 seconds. So down below we were getting 72. If we compare this to previous tests, the fastest we ever saw the pit empty at 375 with certain coal type was 75 seconds. We're 68 seconds emptying the pit with this coal on this test.